Hello everyone. Today's learning objective is students will be able to describe the components of an atom and elements. Please take out your notebooks to write notes and open IS-4 Experience 1 Nearpod. Thank you. Our objective for today is students will be able to describe the components of an atom and elements. Please take out your notebooks to write notes. Our warm-up question for today is, what is the area around the nucleus called? Use your notes from IS-1 Experience 3. The title of this chapter's notes is IS-4 Experience 1, Isotopes and Atomic Mass. The answer to the warm-up question was electron cloud. The area around the nucleus, which is the center of the atom, is an electron cloud. Inside the nucleus are protons and neutrons. While this picture is very similar to IS-1 Experience 3, there are some key differences. The first one is that the nucleus is shown to be much smaller than our original picture. We also have some symbols, charges, and masses that we now know about these particular subatomic particles. Proton has a symbol of P positive, where the positive is a superscript similar to an exponent. Charge is 1 positive. Notice how the number 1 is shown before the positive symbol. This is only done for charges. Mass, about 1 AMU, or atomic mass unit. Neutron. The symbol is N to the 0. Charge is 0. And the mass is similar to a proton, about 1 AMU. And electrons in the electron cloud have a symbol of E negative, charge of 1 negative, and a mass of about 0.0005 AMU. In our old notes, we learned that the mass of an electron is negligible, which means that it essentially does not change the mass very much. However, electrons do have mass and volume and are considered matter. Which subatomic particle or particles account for most of an atom's mass? Choose all that apply. Go back to the slide of the notes we just wrote down and choose which one accounts for the atom's mass. There also may be more than one answer. The answer was proton and neutron. On the next slide of notes, there are a lot of vocabulary terms. First is the term element, which means the simplest form of matter. While we learned we can change the name of an element using the number of protons, we did not necessarily discuss what the actual word meant. The word element essentially means if you take any atom and you determine that this set of atoms has this number of protons, it is considered the simplest form of matter. The atomic number is the number of protons in the nucleus. We name elements based on the atomic number. Atoms are electrically neutral, which means the number of protons and electrons are the same. Mass number is the number of protons and neutrons added together. The mass number uses atomic mass unit, or AMU, instead of grams for mass. And isotopes, by definition, have different numbers of neutrons and mass numbers. On this slide, do not draw this slide in your notes. This particular picture is directly from the periodic table. Let's go over each of these numbers and symbols in the boxes of each element on the periodic table. On the top left, we have the atomic number, or the number of protons. By definition, this is also the number of electrons. On the top right is atomic mass. This is the number of protons and neutrons added together and is the weighted average of all of the isotopes that exist in nature. On this particular periodic table, it provides an element classification symbol. You don't necessarily need to memorize the symbols for the classification. You just simply use them or just use the colors that this periodic table uses. In the middle is the element symbol. Element symbols are always capital and then lowercase letter if there is a lowercase letter after the first letter. The symbol we have here is capital A, lowercase l. We are accustomed to some fonts in English that use the capital I that looks like a lowercase l. In order to not get confused with this, the second letter is always lowercase. On the left, we have the phase at STP, where the different symbols indicate solid, liquid, or gas. STP stands for standard temperature and pressure. The standard temperature in Kelvin is 298. In degrees Celsius, that's the same thing as 25 degrees Celsius, which is a little bit warmer than room temperature. The pressure for the standard pressure is essentially the pressure at the ocean or sea level. We typically call that 1 atmosphere or 760 millimeters of mercury if you read a barometer. Underneath this is the electron configuration, which we will learn about in a future chapter. And on the bottom is the full spelling of the element name in American English. I bring this up because, for example, aluminum in other countries that speak English is pronounced aluminium, where the spelling has IUM at the end. Most elements like sodium, calcium, and others do end in IUM. But in American English, for this example, we have aluminum. Other countries, such as those who speak Spanish, would pronounce aluminum aluminio. Our next question is, fluorine helps to prevent tooth decay and is found in many tubes of toothpaste. Here is an example of some toothpaste. The term fluorine is not necessarily the spelling we see for toothpaste. We usually see fluoride. The term fluoride versus fluorine is the exact same element in terms of the number of protons. The ending spelling is because fluoride is an ion, which we learned about the definition of that before, where the number of electrons is different. However, fluorine or fluoride is very healthy to use in small quantities directly on bones, such as your teeth. We drink fluoride to also improve our teeth and bone function. That is found in our drinking water as an additive. However, we teach young children to not swallow toothpaste. This is because the amount of fluoride in toothpaste is very high and can be very toxic if swallowed too much. The next example is iodine. Iodine is often used to clean skin before surgery. I apologize to anyone who does not like needles, but please try to focus on the orange liquid in the center. That orange liquid is betadine, which is iodine and potassium iodide mixed in water. It's an extremely useful and effective solution that we put on people's skin to kill bacteria and viruses very quickly. While it is very effective, it also stains skin orange for a few weeks. Identify the number of protons and electrons in fluorine and iodine. Here's how you do this. In your notes, you wrote down which number on the periodic table you can use to identify the number of protons. That number is the atomic number. We also wrote down that the number of protons and electrons are the same. We can go to our periodic table for the class, which can be found in Google Classroom, and find fluorine and iodine. Both of these elements can be found on the far right-hand side in the pink area. Using the legend at the top middle of the periodic table that we saw in the Nearpod lesson, the atomic number is the top left number. For fluorine, the top left number is 9. Let's go ahead and write or type the number 9 for fluorine, for both the protons and for the electrons. Let's do the same thing for iodine. Iodine is number 53. So let's go ahead and type the number 53. And here is our final answer. In our next set of notes, we have some more definitions. First is the definition of the periodic table. Periodic table is an arrangement of elements in which the elements are separated into groups based on a set of repeating properties. Elements above and below each other tend to have similar properties. Each element is represented by a 1 or 2 letter chemical symbol. Chemical symbols are capitalized on the first letter, but never the second letter. Our next question says, based on the organization and colors in the periodic table, which 2 elements do you think are most similar in terms of their properties? Magnesium, Mg, barium, Ba, and gold, Au. And explain. In the notes we just read about, in the second line, we learned that elements above and below each other tend to have similar properties. On our periodic table, you can see that the colors show columns, or vertical or up and down, however you want to think of it, elements that are similar to each other. So out of that list of 3 elements, either using the colors or the fact that elements are above and below each other, which of the elements on that list are similar? If you're having a little bit of a hard time finding those elements, here they are. Mg is number 12 in the orange. Our next one is barium, which is here on the bottom left in the orange. And gold is found on the bottom, closer to the middle of the periodic table. The answer is magnesium and barium are above and below each other. If you chose barium and gold, you missed the concept of this. The rule is above and below each other, or at minimum in a similar color on this periodic table. Here's an example answer of how to word this. Magnesium and barium are above and below each other, so they tend to have similar chemical properties. And lastly, did you meet the learning objective for today? Please choose A through E, one of the answers. And that's it for today's lesson. Thank you very much, and I'll see you next time.